Hello and welcome back to the Programming Bootcamp. Hi, Nora. Say
Hi
something.
everyone.
Otherwise, Zoom won't start showing you. Anyway, so welcome back. We are going to, in this video, we are going to go through all the exercises of the file chapter. Okay, so I'm sharing the screen just for a second, so people will see the main slide, this one, and then we switch to the slides is the files chapter. And since actually we recorded the previous video and we went over the exercises, I added at least one more exercise, and probably I'm going to add more. And so after we go over the solutions and your questions, then we can also look at this extra exercise, and then you can go on then do more exercises later on. Okay?
All right.
So let me, if once I find it, I can stop sharing. And now it's your turn basically. So
Yes.
please show
Okay, let me share the screen. Right. So this is the first exercise, I think, that we had, which was counting numbers, which we did before, but now the numbers come from a file. So what I did is essentially I used the same function I used in the previous exercise for counting the numbers. The only exception is that I had to, except for just doing this bit, obviously I had to open the file and make sure that there are no new lines in that file, and then make the file into just a string, splitted by actually not a string, into a
numbers. Okay.
Yeah, into this by splitting them according to spaces.
So you have
if I remember correctly.
just to so remind myself as well, the file has sets of numbers, each number,
Yes.
and spaces between numbers. Each number can have multiple digits, and then we have multiple lines of these numbers basically.
Yes, these sets of numbers.
Okay.
Yeah, and then I did the same counting. So this digits list was the counter for me, and this was the algorithm for actually counting the digits. And then at the end, I opened a new file, which is the report file for writing. And then this is the expression that I wrote into the file. So again, I iterated through the list and then printed out all of the digits one under the other.
Okay. Any issues you had with
No, with this, not with this.
Okay. So one or two comments here. I mean, first of all, it's good that you use row strings if you already hard-coded your path to the file. But actually, it would be much better if the passes. So if you have to hard-code passes, then it would be better to put all these hard-coded file names into variable names, just like you did the first one. I think in the first one was
the first.
So the second one probably it would be better to put that also in a file in a variable name at the top of the program. So if someone needs to change something, then it's going to be easier. And even better if you actually got these values from the user instead of because now this is something that I encountered many times when people in my courses submit exercises that I can't run this, and not only because I don't have normally I don't run Windows, just now I'm running, but usually I'm on my Linux environment, and on Linux you don't have this C something, but also I don't have this specific path.
Right. Yes.
Yeah. So I have to edit the file in order to run it, and then it's not generic enough.
Right. Okay.
Yeah, so it's much better to accept file names on the command line.
Okay.
And if you and then one thing that I do also I think for my slides is that I have default file names, but I accept from the user on the command line, and then it can be easily tested by other files, but because I'm lazy, I don't want to type them in every time. So I have them fixed in the example files I have fixed in the script.
Right.
Okay.
Yeah.
So for the example, for the exercise, it's good because there you probably have a fixed file actually.
Yeah.
Okay.
Did you have something else?
No. That's just
okay.
That's it.
Okay. The next one that we had was the stripping the new lines, which is this one. This was just a script, no function at all. Here I actually did this input, but not with command line, but
right.
Yeah, could do that too. Here we just had to strip the new lines from all of the lines from the file and then put it into a list. That was the task.
Okay.
So yeah, this is the list. Open the file, and with each line, I removed the rightmost new line, and then obviously append it.
Okay.
Yeah. Okay. The next one we had was the color selector. Here, this bit, the color menu function is almost the same as the one from the previous exercise, from the previous chapter. The only difference is that I took out the bits that would prompt for the color itself on the command line, because we had that in the last exercise bit of the previous chapter. But other than that, this is the more important bit. So I actually had a question here. I did this, right? This bit, which would be, if there is a command line argument, then take that as the file name. And if there isn't, then this is the file name that we use.
Okay.
But here, what I realized that if I enter something on the command line, which is not a usable path, there is no such file, then obviously I get an exception and it says that there is no such file. But if I enter a correct pathway to a correct file, which is not the same as this one, it still opened the same colors file, which was weird for me. I don't know if I misunderstood something or
I don't understand why would that do it. Can you try to show this?
Yes, I'll try to show it. So I have other.
If you give this one as the parameter, then obviously it will.
No. That's not what I intend to do. I just have to check what other files I have there. Okay. So now I'll share the Anaconda prompt. You can see it now, right?
Yeah.
Okay.
How do you switch between? You drag the window inside somewhere, or you actually zoom? You change?
I start a new share, because I usually only share not the whole screen, but but only the window.
Okay.
So here I have the color selector. Oh right, I didn't add any argument. Obviously, I'm stupid. Sorry.
No.
Anyway, yeah, I'm just rushing. Anyway, okay, let's start again. So it's Python color selector, and then this would be the path, and then I have something there called report, for instance.
Okay.
Report.txt, and it still gives the color menu from the colors.txt file.
So what's in the
even though in the report file there is numbers. It's from the previous exercise.
Okay, let's see that. So Control C here.
Okay.
And then first of all, type in with up arrow, just with the up arrow, with the up arrow, and then remove the first of all remove the last. Remove the last part except of the file name.
Except of the file name. Okay.
Except of the program, yes. And now jump to the beginning, so you can press home, I guess. Here.
Home, yes.
And then just remove that Python, and instead of that, write in type. So type in type, yeah, and enter. So okay. This is this. It looks like this looks correct. So right, I don't know. So the other thing is just to show what is actually in the other file that you gave it, the report file.
Right.
These
Let
are
me
like the
open
basic
that.
things I use because I don't think at this point any problem with the code.
Right. So the report file, now you can see that window. It has simply digits.
Okay. Okay. So okay. So at this point, what I would do is because we haven't learned how to use an IDE and how to use debugging features there, I would insert print statements. So on the line 31, for example, I would print out the what actually is in len sys
Okay.
And then on line 36, I would print out the name of the file. So the file name.
Right, okay. Like this, and then here just print out the
36, yeah.
36, right, okay.
Yeah. Just print file name.
Okay. Let me share this. So
yeah.
Do you want me to use this report file again?
Yeah, that's okay.
Okay.
So it says 4. Oh, okay, okay. I see the bug now. That's interesting. Do you see? Can you see the bug? Can you see
the spaces.
Right. Yes.
Aha. Okay.
So the program is good. It's working fine. Probably. It's just the user has a problem, right?
Right.
It's the user.
Yes. Okay.
It's like okay. So Control C now, and then run it again, but just this time put the this one in quotes, in double quotes. In double quotes. I think that's.
Oh no.
Yeah.
Okay, double quotes, and then
not there, just in front of
there. Okay. Okay.
Okay.
Right. Right. This is good.
This is now it's using that as the source. Okay.
Right. Okay. So that's why I'm not supposed to have spaces in my folder names.
Yeah, that's a good reason for that. Right.
Okay. Then let me go back to the code. Yes.
So it's actually a question. How could you actually protect yourself from this?
Could I do like this?
Well,
or does that not help at all?
Your cursor is just above what you wrote. So
oh, sorry.
I don't see it. That won't help because the problem is that you never entered it, actually.
Right. Okay.
You never entered, so the if statement is false there.
Right.
So basically what you have here is that if you don't give a parameter, then you would like to get the default file. But if you give a parameter, then you would, so our problem was that we had more than
too many, yes. Then should I say more than 2, more than or equal to?
So I guess you would probably have 3 cases here. One, if the user doesn't give any parameter, then you have the default file. If the user gives exactly 1 extra parameter, so if it's equals to 2, then you do whatever the user gave. And if the user gives you more parameters, then you probably complain because there's no reason to give more parameters. It's probably because the user passed something incorrectly.
Right, okay. So should I add an elif here?
Yeah. That's also good, yeah.
If it's more than 2, right?
Yeah.
Then print error.
Just exit maybe, or
okay.
whatever you, I mean, yes, you can print and exit or just directly exit.
Okay.
And then you state something that is incorrect, right? Yes. Okay.
Right. Is there anything?
Shall we try it?
Okay. Okay. Right. Let me share that screen. So now.
This one. Try this one. This should still work. Okay.
Yes. Okay, and then this one without the quotes.
Yeah.
And then it gives too many arguments. Okay. All right. Right. So on to the next exercise?
Yeah, sure. Go ahead.
Or do you have anything else?
No.
Here? Okay.
No, I mean, there was a bug. We solved it. I mean, the reading of the file is pretty straightforward.
Yeah.
I just wanted to have some practice, but it's an interesting bug that we had. So.
Right. Yeah, the next exercise was the rotation 13 decrypting and encrypting exercise.
Yeah.
Yeah, this was actually interesting because when I first did it, obviously I didn't think of how lists don't go around with indexes. Okay. So first I just made one list like this, but then this is the way I solved it in the end, that I just matched up the 2 lists that I made using okay. Using their indexes.
Mm-hmm.
Yeah, the list bit was just because I was lazy to actually type in the whole list. This was easier for me to type it in as a string.
Oh, sure.
And then turn it into a list. And then at first I did the whole function bit, and then I used the bits with where you actually have to enter the file name and the path for the file. So this was the actual function for returning the roth13 code of each letter in the entered string.
Yeah, so I see that you uppercase everything first, and then you just do
yes.
That.
And then I also allowed for stuff to be entered, which is not a letter. So if there are special characters entered or numbers.
And then what happens? So if
it just gets appended the same way, in the same place as it would otherwise. It just doesn't get translated into anything else. It doesn't get encrypted.
Okay. So it's interesting that you basically what I see that you go and take a character. So if you have a character, so line 6, you go over each character, and then line 7 you check if it's in the first alphabet, so in the first 13 letters.
Yeah.
And if it's there, then you look up is using index inside there, in the square brackets. What is the index? So what is the location of this character? And then look up what is the same character in the other list.
In the same location, yeah.
In the same location. So in the same location in the alphabet, in the second alphabet, and then you append that to the rotated text.
Yes.
Which is the text row, and then you join them together. So
Yes.
it's interesting. I think my solution would be just a mathematical solution. So taking each character, getting its ASCII value.
Right.
Adding 13, and then do the modulus because they're going around, and then adding back the basic the base number that's
right. Okay.
Okay. In a way, your solution is more generic, but because you can set any mapping here.
Yeah.
So the default, like more standard or certain solution is just really rotating 13, but your solution allows to create any mapping between any set of letters, and then it works, right?
Yeah.
Okay.
Yeah, the end was just to open a file again from input. I could have done that with command line now as well, but
right. So you have the file name, which is a file name, and then you have a variable called file, which is slightly confusing to me because you append to it, so it's not a file actually. It's some.
It's a list.
It's a list of that contains the lines.
Okay. Should I call it lines?
Whatever makes sense to you. Just come back.
This made sense to me, but apparently it's confusing.
Come back to the same thing a month from now, and then figure it out. What was the meaning of each variable, and then that's the good exercise.
Okay, now I'm confused. Just
leave it file. Just leave it as file. Okay.
So right. Okay.
Your new exercise is going to be 1 month from now. Go over your solutions and let me know if you still understand your solutions. And
yeah, that's gonna be tricky.
If something is unclear, then you have to understand them, and then if you think at that point that the variable name could be improved, then you do improve it. Okay.
Right.
That's like a long-term exercise, but I think that's one way how you improve, because you look back at your code and you say, okay, how did that? I mean, I do it all the time when I look at some old code and I look at it and say, the person who wrote this is just totally out of their mind, and then look at it and then say, okay, I wrote it half a year ago. It's a standard thing. So right. Okay, let's go ahead to the next exercise.
Actually, I had one question here. So when I was doing this bit, because I was supposed to rewrite the original file. Mm-hmm. What I found actually on I think on Stack Overflow was this possibility to use R+ to open a file, which would allow for writing and reading at the same time. But when I did this, so I wanted to combine these two statements, the two with statements together, so I wouldn't have to write it out again. But when I tried that, interestingly, what it did was to write out the stuff that I wanted to write, but it didn't replace the original values.
It added.
So it just, yeah.
So right, it's almost always when you make some changes to a file in a programming language, the standard way is to read the whole content, make the changes in memory, and write out the whole content. So the way that exists now in your solution. Using this R+, so having a file opened and for reading and writing at the same time is much more complex to get it right. The whole operation, and it's only needed if you really need. It's rarely needed. Okay, it's very rarely needed. It's only probably needed if you somehow want to make sure that while you are editing this file, okay, so that between the time that you read the file and then you write out the new version of file, no one changes the file. Okay, not no other process in your computer. So, and that in that case, that's not what you usually do. You open the file for reading and writing at the same time. You lock the file. So there is a way to lock the files. I think actually on Windows you don't really have to, because Windows automatically locks the files when they are open. On Linux you have to lock it, and then you have to deal with all these things that what actually basically all the programming languages have on these operating systems like Windows and Linux and Mac, is that when they access the file, they have something like a pointer that points to where they are currently in the reading or writing, whatever they do. So when you open the file for reading and writing, this is at the beginning, this pointer, and as you read, this pointer goes ahead, and and probably you stopped reading at the end of the file, but then this pointer is at the end of the file. So if you write now, then it will write to the end. So you now, in order to rewrite the file, you have to rewind this thing. There's a function called seek that we could move this thing in the file, and then you write and then you can move it to the beginning of the file and rewrite the whole content. And in this specific case, because the input file and the output file is exactly the same length, that's still okay, and it's relatively easy. But if the length of the file could change between from the input to the output, then it's going to be difficult, especially if the file gets shorter. Because then it's not enough to write the new content. You also have to tell it that remove the leftover, truncate the leftover. That's actually the name of the command. And it gets really messy, and usually it's not worth the effort. Okay, so although it looks sort of nice, I can do it at the same time, but in fact it's not what usually what we do. Okay.
Yes, we had one more exercise, which was the combining of two files.
Okay.
Now here I had a couple of issues. Again, I didn't use, I used standard file names and paths. I didn't use the input here.
Okay. I mean, I usually say hard-coded, but yeah, okay. Not standard.
Okay. Right, so here I had the two original files, and I just created an output file called combined.
Okay.
And then I created all these lists, which will be used later on. First, what I did was open both files and read each line into this list called all.
Okay.
Without the new lines. Now here I already had one question, which was how would I be able to combine these two, because they're almost the same, obviously, just with different file names.
Right. So if you already learned functions, then you would probably hide it in functions, or you could actually loop over, so with a for loop on the file names.
Right.
And for each of the file, you open the file and read the content and put it. So that's the other solution. Would you want to change it to that now?
I could. Yeah.
Yeah.
So here I just say for. Wait, how should I create like a list of the file names, or
you don't need. You can on the fly create.
Okay. Here. Okay. So, for what should be the name? I guess file. Like that?
Yes, exactly.
And then, wait, this, I didn't want to do that. This should be file then.
Yeah.
And this doesn't really matter what this is.
Right. I mean, it didn't matter earlier either, so you could have used the same FH in both cases.
Yeah. I know that it was just a bit confusing for me when I had to write it 2 times, so that's why I did it this way. But so then I don't need this.
Right. And you don't need the comment. Yeah.
Yeah, I do not need the comment as well, but it's good for me to be able to look over it again. And then this should be like that.
Right.
Okay.
Okay.
Right. So then I iterated over all of the items in this newly created list with everything in it.
Okay.
At this point, what we put in it was a word, like strings, consisting of a vegetable name or a plant name, an equal sign, and a number with no spaces between. That was the format of the file.
Yeah.
So here what I did is to split each item according to, like, with the separation of the equal sign. So I would end up with the name and the number separately.
Okay.
And then for each item in the item, this variable was plant or amount. If it is a number, so if it is decimal, then I would append it to this list I created before called amounts. And then otherwise, if it's not a number, then it should be a string, it should be a plant name. Then I would append it to this list called plants.
Okay.
So now I have the two lists which have the same indexes matching to the numbers and the names of the plants.
Yeah.
So now here I created two new lists again. The unique one will contain all of the names of the plants, and then the added values will contain the numbers added up when there is more than one appearance of the same vegetable. So now I iterated over the plants list, and I got the index of the current plant that we're looking at.
Yeah.
First of all, and then if that plant was already in the unique list, then this was so confusing to write as well. So it's confusing to read as well, I would imagine. But I used indexes to find what the first appearance of that vegetable was.
Right.
Actually, the next appearance. So this was my issue here, right? That this way I can only catch the plant that is named twice or three times. I can only catch it if it comes two times. So if I enter it a third time or a fourth time, then it doesn't work because it always finds the index of the second appearance. So I didn't know how to solve that, but here in the files that we had as an example, we didn't have anything that was that appeared more than twice. So I was lucky with this one, but I know that this is an issue. So yeah, and then I would use the same. I would find the index of the same vegetable in the unique list as well, and then I would add the two amounts together. So find in the amounts list, find the value that belongs to the same index as it was in the plants list, and add it to the amount that is the same index as the one in the unique list.
Right. Yeah. You seem to. Also in the previous exercise, you used a lot of these indexes.
Yes.
Looking up, and that's right. That's
slow.
That's slow because then it goes over the whole list again and again and again.
Yes, I didn't know how else to solve it, so that's why I did it this way.
Okay, so if I just gave you a list on paper, what would you do? Just on paper, not computers.
Just on paper. Like what do you mean?
Yeah, right. I know. It's difficult to remember. There's a piece of paper like this.
Yeah. No, I remember. Yes, yeah.
So,
like if you gave me the two files.
Yes, just the two files. What would you do?
Well, I mean, I would look for the same word and then add the values together and then write it down again.
Would you take the first word, go over all the file and add them?
No.
How would you do that?
So I would like take the first one, write it down, take the second one. If it's different, write it down. If it's not different, then just add it to the first one.
Right.
Yes. Okay. I get your point.
Do the same with the computer. Okay.
Okay. Okay. Right. I don't know how to do. That's the issue.
Okay. So let's go back up to the beginning of the file. So okay, so it's okay. You read in the content of both files. I probably wouldn't do that. I wouldn't probably separate the reading all the lines and then doing all the processing. But it has also value, so let's leave it that way. Okay, so now we have all, which is all the rows. Okay, so let's go further down. Here you go over. So first of all, here I have a question. What is item?
It's a string.
Is it
contain? Yes.
On line 23. On line 24, what is item?
Here it ends up being a list.
Right. So
because of the split, right?
Yeah. So that's not a good idea to reuse the same word, the same variable,
okay,
because that's confusing. So let's rename that item to something else.
Okay.
It's easier to rename well, yeah. What is that? What is in there actually? It's a list, but a list of what?
Of a plant name and the amount. Okay. That was.
How many elements are there?
2.
Okay, so I would call them pairs probably.
Okay. Okay.
Okay. Now this is another thing. What you do here is you go over the elements of these pairs, and then based on the type of their value, you decide whether it's the name or the value. But it's very limiting in a way, because what if I in this file I didn't have plants but numbers and how many times they appear. Now both sides are numbers.
Mm-hmm.
It's much better, and I can also imagine that I have a word, and on the other side also I have a word for some other activity. So I think it's much better to base on our decision on the location of this. So we have pairs in the index 0 and pairs index 1. And we know that pairs index 0 is the plan.
Yeah.
So so that's one thing. But I can go even further. So you can actually, instead pairs, you can write a plant, comma, amount instead of pairs. Okay, so now when split works, so in this case, if split actually splits up to more than 2 parts or less than 2 parts, then Python will raise an exception here. So it's in a way more restricted. But on the other hand, if we can assume that our input always has exactly an equal sign, then it works.
Okay.
Okay.
So now I would have to just say, no, actually this is amount, and this would be plant, right?
Right, and you don't need
all. Then I don't need anything else.
Yeah, not the if statement and not the loop. Okay, so that's one thing. But why do we need to store them even? Why don't we go straight to counting them to the unique and word? So why do we need these extra lists?
We don't really. I only use them because a way to match them up was, in my head, the easiest was to use the indexes.
Right. So I think you don't need these 2 lines. You can comment them out for now, or just so they have it. And then instead of that, you put So we needed this unique and added because we needed the two reports, right?
Yes.
Okay, so if you need them, then just move them above the for loop because the above the 23. So you will have that, and then you don't need the second for loop.
Okay, yeah, because
there's this for loop. Sorry, the loop on line 31. You don't need.
Up to.
Well, no, I don't remember the content. Just don't remove the content yet. So you just. So now we go over the plan. So every iteration we have a plant and an amount in our hands, right?
Yes.
And then you would like to check whether it's already. So what was the unique was the list of the unique names, right?
Yes.
So if these unique names, then actually you don't even. Then maybe it's better to use them as a set, no? Or do you need
a set, right?
It's not a location. If the location doesn't matter, then just have a set.
Yeah, okay.
But define the uniques at the top as a set.
How would I do that?
Write that and then equal to set. And then, yes, I think that's it. That's enough.
Okay.
And then you say unique, I think add so it's in on line 29.
Okay. And which line? Sorry.
20,
here.
29. No, 20. Well,
29. Oh, okay, okay.
Yeah. So we are in just a loop. So I think unique dot add and then plant, right?
Plant, yes.
Just indented indented a little bit. Yeah. And then the other one is what is the added? So it's so you have, wait a second. You had the unique was a list of the plants, and the added was the how many each time they have, right? So
yes,
it's not that good.
The actual amounts added together.
Okay, so then but actually then it's not unique and added, but then they are plants and amounts.
Yeah, but at this point, I already had a plant and amount for the previous.
Right,
but I didn't use. Okay, yeah, I'm not using that now.
Because... No. What I'm saying, okay. So what I'm saying is that in the unique, so probably it wasn't a good idea to turn that into a set because you need the location of each plant in your list. So maybe it's better to just go back to the idea of having them two lists, but we call them plants and amounts in the end.
So then I don't need this.
You have all those. You already had them. Okay, so
yeah, but it's easier to look over for me if they are closer to wherever I use them.
And amounts, right? Okay, and then you don't add. And now in this case, you need to find whether this plant is in the plants, right?
Yes.
So you ask if plant in plants, or at this point you probably need the index.
Yeah.
But I mean, first probably it's good to check whether so what the bait actually. So now I'm starting to understand why you were doing the what you did in line 31. Okay.
Yes.
So so basically. Okay, so you can remove the line 29 because that we already in the loop, right? And then you say that in the plants you are looking for it's not veg anymore, but plant, right?
Okay, so
just keep the line. The parameter is not veg. Well, you can plant, vegetable, whatever. Yeah.
Yeah.
And that's in index.
But wait, so for now.
Right.
We have not added anything to these lists, so these lists are still empty.
Well, so it depends. On the first iteration, you don't have anything yet. That's right. But later iterations, you do.
Okay.
So.
Oh, right. Okay.
Right.
Okay.
So, but what you probably would like to know first is if the if the current plant is in the plants.
Yes.
Before you are asking, so before you are trying to figure out the location.
Okay, so this would be the first thing.
Yeah.
Okay, I'll take this for now.
Let's just swap the two lines.
Yes, that's what I was gonna do. But not in unique, in plants.
It's plants, yeah. So. And
this should be plant as well, right?
Yeah, right. So if this plant is in the plants, then let's check what is its ID, what is its index.
Index.
Okay, and then you don't need this searching thing. So you don't need line 31, line 30.
Okay.
Nor line 31, because we assume that in the amount list, it's in the same location.
Yeah.
So that's what you had in line 32, actually.
Yeah, okay.
What you have now. It's just the names are slightly different.
So we don't have...
You don't need... you can
just
IDX. It's easier because it's the same ID.
Yes, it's going to be the same thing, yes. Because we don't have two separate lists now.
We have two lists, but they're...
I mean, not like two separate lists containing plants. Because previously I had one which contained all of them with repetition, and then I created another one which didn't have the repetition. But now we don't have that, yeah.
Okay, so just now you have to fix the names here. So you're counting in the amounts.
Amounts.
So on the left-hand side you have amounts. No, you don't need that actually.
Oh, I don't need it. Okay.
You can there you have amounts. And then you put in a plus equal instead of this.
Okay.
And that, and then you remove that, and there you have
amount. Just simply.
Yeah. And you have to convert it into int because otherwise it would be just a string. No. Oh, you did it already on the right hand side.
This one. I mean, right. So this is right now.
Yeah, so the variable amount is a string.
Yes, yeah, okay.
But then every time you will convert here and then, right, okay. So this is if the plant is already in the plants.
Yes.
And if it's not?
Then I have to append it. And this is amounts.
Mm-hmm.
And this should be... It doesn't matter what index I use here, is it?
You don't need an index there. You put the amount in there.
Just amount, yes.
Well, not
Should I use?
Mm-hmm. Right. Yes. Okay. And then, so I think this is okay. And now the reporting part is.
Okay, so I don't have this anymore.
I mean, I would go over the index.
Over the index.
Yes, because that's common to both of them.
Right. Okay. So should I use range?
Yeah.
What was it? Plants. Right?
Yes. Oh, so we are ordering them now.
Well, because in the example that you gave, the expected output was put in alphabetical order.
Okay.
So that was just the end. Sorting them.
Yeah.
This should be +1, right? No. No. Yeah, that's right.
Okay.
And then.
Right. So now let's skip that ordering part now for.
This one or this one?
What? Just print it out. Okay. The whole thing.
Okay.
The whole ordering thing is.
Okay. So this. So print, what was it, plants. This should be a string.
No, okay.
With an equal sign. And amount also I. Right?
Yeah, okay. And then you don't need the, well, at least you can comment out the writing to the file now that you have 40.
I mean, that was the whole point, no?
Yeah,
to have it in a file.
Let's do it without it for now. Let's see
okay.
if it runs properly, and then.
Okay. Let me share the prompt. Okay, so now it's Python. What was the name? Combine. Yes. Okay, this is right.
Okay, so let's go back, and then now you can write the whole thing into a file. So instead of printing to the screen, so this whole loop that, which I mean, the same loop that you have on line 38, you have the same one. Just no, I mean,
yes.
First, you need to open the file, and then
right.
Instead of print, you write to the file.
Okay. Right?
Yeah,
and then
yeah. Mm-hmm.
Yeah, they are the only difference here is that they're not in alphabetical order now.
Yes, yes. So yeah.
But I mean, if we don't need that, then it's fine.
Okay, so this works?
This should work. Let me check again. I run it again, and then in my files, this should be the combined text.
Mm-hmm.
And it works.
Okay, so in Hungarian, nice. Okay.
Yes, yeah, my computer is in Hungarian.
Good. So you can, if you would like, we can go on now and make it alphabetical order. I don't remember how I solved it in the exercise, but I can show you what I would do here.
Okay.
So maybe you would like to save this and then have copy this file. And
okay.
So we have this solution
right.
and then the separate solution for the other one.
Okay. Let me create a new one. Combine.
And you can combine and you can file tuples, you can say. Okay. Okay, so now
let me just get rid of the stuff that we don't need anymore.
We don't need. Now we don't need. So what we are going to do now, instead of having two lists, okay, we've learned about tuples, right?
Yes, we did.
So well, actually, okay. So just let's continue this. So let's go to the end. Once we are done, let's create first a list of tuples. Okay, so just before the saving. Okay,
before the saving.
Okay, so on 26, you create, I don't know what name.
Tuples.
Together now. I just call them both. I don't know. I have no idea. Better idea now, and it's just a list. Okay. And now we go over the list. So the first thing is that we go over the list, and then we create, so just copy the line 31 and even 32, you can. And what we do is append to both, to the variable both. So instead of outright, you have both dot append. And then instead of a string, you just create, you put in a pair of parentheses. So you need another pair of parentheses, I think.
Yes.
Actually, you don't need, no, probably not. Just that's it. Yeah, you just remove these things. Okay. So that's it. And now let's just have it just so on line 31, just print out the content of both.
Okay.
Indented out. Okay. Print just both. Okay. And then we'll find a better name for this. Okay. So for now, just run it.
Okay. I'll just let me do this.
You can comment it out here.
Okay. Let me share this screen. So combine files, tuples.
Okay. Okay. So probably you need to put in the another pair of parentheses in order to make that a real tuple.
Okay. Like that.
Yeah.
Okay. Let me run it again.
Okay.
Yes.
So now we have a list of these tuples. Okay, and now we can run a sort on this list.
Right.
Okay.
So now
here, there, just write both dot sort. Okay, and run it again. Better without CLS, just run it. So don't clear the screen. Okay, and now it's sorted. Then
yes.
ABC order. So because it works on the first element of the tuple, the sort.
Yeah.
Okay, and now in the next loop. So when you open the file, you actually iterate over the tuple.
Okay.
The list of the tuples on both. And it's the same thing so far. And just now you have in the outright. So first of all, you probably on line 34, you would say instead of plans, you would say both. Just
yes.
Even though they're the same lengths, but just it's like linear. And then there you have both.
So how do I?
Okay, so actually now you don't need to iterate over the index.
Right. Because I don't use the index.
What you have now, so instead of I, you have a pair, let's say.
In both.
In both, yes. And then you outright pair location 0 and equal to pair location 1.
Okay, so 0 equal pair location 1, and this is all in.
Yeah, the whole thing is a string.
But it's a format, no.
Yeah, so you see, it's like earlier. It's just you take out from the tuple the two parts.
Yeah. Okay.
And the new line.
Oh yeah, the new line, of course.
Okay, and then you can run this now.
Again, it's ordered, and now let me go to the files and let's check combine again. And now it's in order.
Right. Okay, so now let's do something else if you're already here.
Okay.
And now in the sort, wow, we haven't learned that yet, but okay, doesn't matter. We're going to learn it. So in the sort, type in key. equal lambda. And then here you say a space, let's say x, just doesn't matter, this is a variable name, colon. No, not comma, colon.
Oh, right, sorry.
And then you put here x in square bracket 1. Okay, let's run this now to see if it really works. And then I explain before. Okay. So what is the order now?
The numbers.
Right.
In ascending order.
Yeah. So you could put in reverse equal to as a second parameter in the sorted. So they put comma and reverse equal to.
Yes.
Okay. So what we have here is that we went over the key, right? And the reverse. So
yeah.
How to sort it. Okay. So what we have here is this lambda. So the lambda is basically, well, it's pretty advanced, but let's go in. What it's basically, it's called a lambda expression. It's a short function basically. So what Python does when it does the sort and it has a key parameter, then when it compares, so it goes over, so sort goes over all the pairs in the list and compares them, and based on these, the result of the comparison orders them. But if it has an attribute, if the sort method has an attribute called key, then instead of comparing the two values, what it does, it calls that function on both values, calculates the results, and then compares the results.
Okay.
So you might recall we had the key equal to len, and then instead of sorting the words ABC order, it was sorting by their lengths. What we have here is that this lambda expression says that the function is going to get a parameter that we just arbitrarily called x, okay? And then because we are sorting these tuples, right? So this x is going to be every time the current tuple that we are comparing to some other tuple. And then x in the first place is the second element of this tuple, which is in our case is that number.
Yeah.
So this lambda expression, that whole thing, tells the key basically that from each tuple, take the second element and compare the second elements when you are deciding which one is smaller and which one is bigger. Okay. And you could do anything there in this any similar expressions, but this way you can actually now sorted the tuples based on the second value, which was the number. Okay, any questions here?
No, I mean, I think I'm gonna have to do a bit of research to better understand how this can be used in other cases, but.
Right, so don't worry about it too much. Usually I teach it in the advanced course, but I felt that it's like a good opportunity to show something that can be interesting and useful. So don't worry too much about it right now. That's what.
Right.
Okay. Did we have any other exercise?
No, this was the last one here. Okay,
so let me just take the screen. I'm going to share the screen and I'll show you the. Okay. Here is my screen. Do you see my slides now?
Yeah, well, the table of contents, yes.
Right, okay. So I added this exercise. Basically, we have now this file, which looks like it's called text report.txt. It's just some random text, but it has several places where we have report and the number. And there are many tasks here. One of them is to start with, I mean, the first one you could even do just get the file as input and print out each line. Then get the file and print out each line that that starts with the word report, or separate exercise, print out each line that has the word report in it. Okay, you could actually then have to decide maybe if you would like to include this line as well, or just the one that has report and the colon and starts with a capital R. Okay, so it's just I just thought about it because I recognize that it has this word as well. Then print out the numbers. So just now, instead of printing out the whole line, print out only the numbers that come after the word report. Okay, then add together all the numbers. So these are all little exercises basically on the same idea, but going deeper and deeper in the analysis of this basically free text file. And then we can also say, so do everything, but now limit your report to everything which is between the begin and the end part. So sort of disregard all the rest.
Okay.
Okay. So yeah, and I'm thinking about some more exercises because we need to deal more with files, but for now it's okay. So I think anything else that you would like to say, add for now?
Actually, there was just one thing that I found separately, that when we were talking about defining functions and about exiting functions using return, I think something that is useful to know that I just learned using one of these exercises was that the return statement actually, if you put after it something, that's what will be put into a variable if you want to use that function to return something. So this was something that I just found out doing these exercises, and I thought that was something
you haven't
useful to mention.
Functions yet, so but it's good that you found it out. Yeah. Okay.
Because we did talk about defining functions before.
Yeah, we did a little bit.
Yeah.
But because I already felt that I mean, it would be really nice if I could always just build upon and always just add teach every the thing and then only use those parts all the time.
Yeah.
That would be like ideal, but many times I need to a little bit jump ahead and show something else.
Yeah. No, I get that.
That's
no, I just thought that this was something useful.
Right. Yeah, that's a good point that you made. Right. Okay. So let's now have this end this video, and then we'll come back to the next chapter, learning about the next chapter. Okay. So thank you very much.
See you.
See you.